Worksheet for 5B columns Berkeley as well. Determine the maximum load that an 8-foot long 2 by 4 inches rectangular aluminum alloy bar, which given the Young modulus and also given the yielding stress, can support with the factor of safety, so Fs equal 3 for both crossing and buckling if it has n condition of pin. So this is rectangular cross section, and they have the n condition. And in this case, the problem don't specify any different in terms of the n condition is about x and y axis. So with that, we assume they have the same n condition for both axes. So let me start with the cross section here, and we have the dimension in that case 4 in the long and then 2 in the width. And with that, let's assume x axis is perpendicular to the long, so that is x, and then the y axis, so it don't need to be horizontal and vertical. This is about the cross section. So we have y. So with that, we already know the ix, iy, how to determine for rectangles, and as you can see, the ix will be greater than iy. So for the columns which have the n condition in both x and y axis, we will find out the smaller I, and in this case iy by my definition of the orientation of the cross section in that way. So here iy is equal to parallel for y, it will be 4 time cross time perpendicular cube, 2 cube divided by 12, and from that we will get it 2.667 inch 4, and the length of this one is 8 foot long. So we will have the L, the length, the actual length is equal to 8 times 12 inch per foot times inch. So from that, it's equal to 96 inch. So we have that one. Now, we need to, for this one, as you can see, they give us the factor of safety for both crossing and buckling. So we have to consider the fail due to crossing and fail due to buckling. But let's consider the buckling first for each scenarios. And as you can see, for the yielding or crossing, it only depends on the cross section and the material. So with that, we will determine it later for all 4 scenarios of n condition. They will have the same failure load for crossing or yielding. So let's talk about buckling first for each scenario. So from that, we can go ahead to find out the critical for each of them. So here it be critical for the case that pins, be critical pins, and it's equal to P critical in y-axis, as I mentioned, because the y, the area of moment of inertia about y-axis is smaller, so it tend to be bundle, tend to be deflect, tend to be buckle about y-axis. Why that? See my demonstration in the part 1 of worksheet 5a solution. So from that, plug in here, it equal to pi square E I y over KL square. Now plug in pi square E, Young modulus, they give us 10.5 times 10 power 3, and then IY just calculate 2.668 divided by Okay, in this case, pins, go back to our lesson note. Pins, pin at both ends, B scenario, K equal to 1. Go back here, it equal to 1 time the length 96 with the total square. From that, we will have P critical equal to 29.95 kips. And the factor of safety is 3, so they ask us determine the maximum load, which is, this is the failure. We want to find out what is the allowable load. And remember, go back to lesson 2 when we know what is the allowable level and failure level with regard to the factor of safety. If you recall, with that we can have the P allowable and factor of safety is equal to the failure level over allowable level. So in this case about load, so allowable level is equal to failure, P fail, divided by the factor of safety. And in that case, P fail in here is pre-critical. So it fail because we talk about the buckle. So fail due to buckling at that pre-critical Fx. So plug in 29.95 divide factor of safety for both crossing and buckling is 3. So plug 3 in. So from that we can have about 10 kips. 10 kips. What does that mean with this column? With that geometry, if it pin at both ends, the maximum load that can be allowed on that material with the factor of safety is 3, it's going to be 10 kips. And the next scenario B is either pin and fix, pin one end and fix as one end. So similarly, we can go to find P critical equal to, again, P critical X, critical in Y direction, and P plug in. It also pipe, same equation. So we have pipe square EIY over KL square is the same. So plug in pi square, same material, 10.5 times 10 power 3, same IY 2.667 over what is K for pin and fix. Go back to here, pins and fix with scenario C, one fixed end and one pin ends, and with that K equal to 0.7. So from that, go back to here, it equal to 0.7 times 96 and square, and from that we can have the P critical equal to 61.14 kips, and exactly the same we can have P allowable equal to pre-critical, the fail, as I mentioned in scenario A, divided by factor of safety, and in that case it will be 61.14 divided by 3. It will get 20.38 kips. So with the same geometry cross section and the length, if the support, if the end condition become to pin fix from pin, and you can see the load, the allowable load is double, twice, from 10 kips to 2.38 kips. The next one is fixed pre. So if you want to model that, with the fixed free. That is the example we did in the lesson note, one fixed, one free for the water tank. So from that we can have fixed free. So we do the same, P critical equal to also P critical in Y critical Y axis, and it equal to pi square E I Y over K L square. And same in here, we can plug in pi square 10.5 10 power 3 I the same 2.667 different K fixed free. So that is one fixed and one free end. K equal to 2, scenario A. So go back there. So that you can see that is K equal to, this is K equal 0.7. Pins, K equal to 1. Just give that for us to have. And let's go back to here to finish with that one for the scenario with a fixed at both ends, K equal to 0.5. With this scenario D, we can go back here to write down. Now, fix, K equal to 0.5. So from that continue, it equal to 2 times 96 square. From that we can get P critical equal to, in that case, equal to 7.49 kips. So we can find out what is the allowable load can apply on this column given the end condition are fixed free. So it will be P critical or P failure due to buckle over factor of safety 7.49 divided by 3. So it will be 2.5 kips. 2.5 kips. So even reduce fixed free, the allowable load on this material, on this column, is only 2.5 kips. So let's move on to the last one with respect to buckling again. So we have it P critical and also P critical in Y axis because the column deflect about Y, as I explained in the demonstration for worksheet 5A, and equal to 5 square 10.5 10 power 3 2.667 over, in this case it's 0.5 time 96 for the length, and power 2 for total. With that equation we will have P critical load is equal to 119.8 kips, and from that we can have the allowable P allowable equal to P critical over Fs, and that equal to 119.8 divided by factor of safety 3 again, it's 40 kips. So you see, for end condition really affect very much about the allowable load for the same geometry and some same material for the column. If it pins 10 kips, go to pin fix, it double, allowable double, 20.38. If it fixed free, it go down to only 2.5 kips, and then fix, it will get the maximum 40 kips, which it makes sense if you have the ends condition is good the buckle chance will be reducing, the maximum allowable load it can be increasing significantly. And now they ask us also for crossing, both crossing and buckling. So far we only deal with the buckling. Let's talk about crossing. And crossing, it will not depend on the end condition. So both on of scenario A, B, C, D, it will have the same load for buckling. Okay, so let's talk for crossing. Sorry, so let's talk about crossing. And here for all four cases for all end conditions, then we have P wipe due to yield, it equal to the sigma yield over A. So that is the failure mode due to crushing, because normal stress equal to P over A. So that this one they give us for the aluminum, and that is 40 sigma yielding stress equal to 40 ksi. So from that we can plug in here. It will be 40 times cross section in that case equal to 2 by 4. So you have that equal to 2 ksi 2 inches times 4 inches. From that we will get it 320 kips, and that is the failure due to crushing. So we can have P allowable due to crushing equal to the yield in load to yield divided by factor of safety. They give us also 3 for this scenario, so 320 divided by 3, you get 107 kips from here. What does that mean? Regardless of the end condition, the allowable for yielding is 107 kips, and compared to the allowable load for buckling, as you can see, the maximum they can get here is the fixed is 40 kips. So it's always for this type of column with that 4 scenarios, the buckle governs over crossings, because the allowable for crossing is so much, 107 kips. So as you can see, from that we can say the buckling governs over crossing or yielding. And that we done for this problem 5B.